So, so this session will be all about scaling, benchmarkings, and hallucinations. So primarily, what we build is an e-commerce system, and while building it, we face multiple hallucinations, ben and also latencies, okay, and scaling issues primarily. And this session will be all about that. So what about us? For my company, it's a core software development. We are working with big tech and startups alike. And we have built 250 products in 20 years. Myself, I'm a bugger who just developed a lot of things, failed a lot of times, and is still failing multiple times, learning. Uh, and my area is scaling. So once people build MVPs and some system, they need to scale. And that's where I put more bugs into their system. So along with me, I have Ritesh Agrawal, who's my colleague. He's a microservices expert, and he has invested himself a lot on GenAI. So large search system, this is in production system we are talking about. So as I said earlier, we did a lot of mess, okay? We failed a lot of times, and finally we get a chance to production, and after 2-3 months of night outs, and that's where we reached this. This is the basic architecture. If you are familiar with e-commerce search, is all about SKUs, shopping items. And primarily here is a very simple architecture. MySQL, which is OLTP, holds all the SKUs in a protocol structure, and that all gets synced back to Elasticsearch using a technology called Debezium. So if you are familiar with it, you can search about it. It's a good technology to sync. And we provide as a mechanism where people can change the prompt. We will come to that, what kind of prompt we are talking about here. And lastly, it goes to Elasticsearch, and the user search provide a search query, and it goes to our Python service, and it uses the embedding cosine similarity. Everybody knows, I believe. So here is the question, okay. So since now we will move about and talking about the scaling, just think about it. This component, right? If you need to scale it, you have primarily two options, okay. You need to hold the embedding, obviously. So now you can have 5 instances which everyone holds the embedding model, or you can have a separate service altogether, and all this service calling to that service. So which one will you use? Which one will scale, actually? That should be the question. How many think first one? First one where you will have 5 instances, each will hold the embedding model itself. It will occupy more memory, but it might scale. That's the option one. Who thinks it will work? Second option is single instance, just one model. All these instances are calling that. So option A, option B. Which one will scale? Option A. Majority of think option A? No, it's option B. So the reason for it is these embedding models need GPUs in order to scale. So for in your laptop, it can run properly. But if you have 10,000 requests per second or 20,000 requests per second, for the similar accuracy which you are getting in your laptop, you need something else. And what is exactly it is? You need GPU. So it's a vertical scaling. Okay. Unfortunately, that's the word it is. We are living there. So very quickly, our scaling production system, we are handling 10 million SKUs, requests per second, 20 requests per second, very high. And it took us for 14 months, okay? So went into the line, and we have nightmares, lot of. Our cluster right now is 3-node Kafka cluster, 2 GD4 X large box, primarily for CUDA cores, and 5 OpenAI tier 3 accounts, not tier 5, and 24 shards with 24 GB indexes to serve the search queries. Very quickly, effects. Our objective is to build a zero-time system. We cannot give product managers to change the prompt, and we cannot ask engineering team to take those prompt and redeploy and get the zero-time. So we have a runtime modification. We very quickly built the POC in 20 days, but it took very first live, not actual live, maybe UAT. It take us 180 days. This is how we did it with one product manager, one engineer, one AI expert. That's it. With 5 AI agents behind the scene. Normally, if you have to do the traditional way, this is the AI way. Traditional way, you need to deploy a team of product managers, each handling multiple e-commerce categories. They will simply invest their time tagging, doing categorization, improving the SKUs, and essentially that part will lead it to the proper search. That's how people do it. Okay. But what we did here is we did it with uh, AI. And if you ask me if you want to build your next system, do you will the AI way or the manual way? With my horror story, okay, I will say go manual way. This is because I face lot of hallucinations using assistant. That's not the way to go. Okay, until unless your objective is scaling. Uh, I don't think we are in the current state. I will talk about more into that. But now we will starting the more technical part. So I will hand it over to Ritesh for talking about semantic search.
Thank you, Ratnesh. Good morning, everyone. So let me give you an example of the search that the user can do and that we are trying to solve. Say, for instance, a user comes into the machine, into the system and says, find me a pink t-shirt for my toddler girl who is 5 years old, correct? So what happens when this is done, right? So in traditional approach, as Ratnesh explained, what we will do, we will convert this query into embedding, and all the embeddings which are already present in our vector store, we will try to do a cosine similarity and find top 50, top 40 results, correct? Now the problem with this approach is hallucinations. When you do this, out of top 50, we found that 2 or 3 results will be wrong. You will find instead of t-shirts, you are getting jeans, or you are getting some wristbands and etc. So now how do you solve the problem? So we spent a lot of time understanding how do we solve it, and we found that all the human users are looking at their screens and looking at the image of the item to say this is wrong. So we thought, why not use this approach with AI? Okay, so what we did, we with all the categories that we had, we created some few hundred test questions, test queries for our system. We converted them, we used that test queries to get all the results from the comparison, which is semantic search or cosine similarity. And then we used the image and the query of the item to send to OpenAI, so that OpenAI can tell us if it is accurate or not. It's just a true or false flag, which we then store in the database that these 2 or 3 SKUs results are not coming correctly for this particular query, so that the admin person later can go and correct them. The name could be wrong, the description of the item could be wrong, right? Because the SKUs are fetched from hundreds and thousands of different sources. Okay, so uh, so this is the hallucination part, and next part. Yeah. So if you look at these, how we converted the embeddings, we used universal sentence encoders V2 model. Okay. So we use the large model for this approach. It requires quite amount of GPU, at least 12 GB VRAM is required to run this model. Okay. And we use large model because this is more suitable when you have categorization and classification kind of embeddings that you need to create in the vector space. But if you are more on some question and answer type of scenarios, then you need to go with the QA model. Okay. So for the storage of the part of the embedding, we used Elasticsearch. There are 4 options, okay, that we think in which we can store embeddings. If you have only few thousand records, then I would recommend go with some in-memory databases like FICE, where you can store data in memory and do the embedding comparisons. If you have a relational database where the data is related to each other, then we recommend Neo4j, which is good. But if you have millions of data records and you want to do comparison, then I would say go with something like Pinecone. Okay, Pinecone will help to get results faster and comparable with the benchmarks. But if you need to do vector search as well as text search, and you need fast response time, then Elasticsearch is the way to go. Okay, So that's why we use the Elasticsearch. Next. So let me explain what is categorization and tagging, which we also saw yesterday in our first paper presentation we had yesterday, right? So categorization and tagging in any e-commerce system is very important. The most important thing is having properly categorized SKUs item in the database, and as many tags for that SKU present in the database will make the search very, very accurate. Okay. So to create this, we started using OpenAI in the beginning, but we found that OpenAI was costing us around $500 for 1 million SKUs to create the tags and to generate the categories. Okay, so we started using the Llama 3 model hosted on a G5X large machine. 2x large machine, sorry, and it cost us around $15 to get it done for 1 million SKUs. Okay, yes, yeah. So, but this whole approach that I explained works well with 50,000 records, 50,000 SKUs, and 13 top level categories. But our problem was to have Google taxonomy categories, which is like 5,000 categories and 10 million SKUs. So that's where scaling comes into the picture. We can go live with this solution directly without any more scaling options here. But now Ratnesh will explain how we scaled from this point. Okay, thank you.
Okay, thanks, Ritesh. So, still with me? Uh, so, before going into the scaling again, I would say just my experience is if you have any plan for scaling, that kind of benchmarking you need to do, you need to start doing from the day one, because once you created the whole thing out, it is very difficult to change. Okay, most importantly with the databases. So databases are like marriage, right? So you are, once you are done, you are done. Okay, you cannot change. It's very hard to change databases. So I can see your pain. Okay. So don't use database if you are not sure. Okay, that's the, so if you want to do cosine similarity, use the in-memory thing. Okay, that's work very well. Once you are done, you are very comfortable. Okay, now search is my main thing, or similarity is my main thing. Then go with Pinecone, Elasticsearch, like that. Okay. Hallucination, very simple. We follow the same strategy. And one of the thing which yesterday, somebody told me that you are building a system with AI, and then you are involving human. And one gentleman said this is wrong. Okay, and I'm with him. He's absolutely right. In my experience, if you are building a system with AI, you need to minimize your humans. Okay, you cannot say, okay, I will create XYZ, and then some people will come and verify the XYZ. You need to build the bots. You need to build those XYZ who can verify those things. Okay, so you need to create the data. Can you create the data using LLM? Perfectly, yes. Very high quality data you can create, and that's what you should do. So here, what we did in order to fix a lot of things, we try to catch the hallucination. So if the AI has generated category and tags, lot of categories and tags it has generated, only thing we want to do whether it has been done correctly or not. So again, same loop. Uh, whatever it has generated and what we have, we are using cosine similarity in memory, not with database, and you are getting almost 95% you will get accurate. Some of them will hallucinate. Okay, and the hallucination, to fix the hallucination, the idea is very simple. Just hit it again and tell them, boss, your last thing didn't work, so send me something else. And most of the time it will be okay. And you can do 2 or thrice attempt and it should be okay. Similarly on the tagging, same thing has been done, but tagging is more important than category as far as search is concerned. So we use the same trick which Ritesh explained. Use the image, get the description of it, and then match against the tags. If those tags are not correct, loop back and ask the process to do it again. If the process is same, nothing change. Okay, and if it is hallucinated, just mark it so that someone can else fix it. Okay, so I will focus on this. Again, very painful item in OpenAI or any LLM per se. And I will, in my opinion, when I'm dealing with multiple people coming me for scaling, I say OpenAI and all this LLM are premium thing, okay? So if you're building a tool, it's like an iPhone. So if you are building a tool, remember this. There is a huge cost involved. So if you have just live in 6 months, you need to pass that cost to your consumers. So are you building that kind of product? Are your user base will pay for your OpenAI calls? If not, then something else you need to do. Okay, so again, it's a premium luxury thing. So challenges here for the scaling, we cannot upgrade the tier. We are still using OpenAI. Token limits, very soon you will run out of it. Classical ways to do the catch and retry. Okay, everybody can do that, very easy. But it doesn't work that way. What you need to do here is very simple answer. Use circuit break pattern. It's a design pattern. Put a layer on top of our API calls, and it will fix it. Very simple. Whether you are using LangChain or any AI framework, whether you are using Llama, just create a wrapper, maintain some persistence, and it will scale. Okay. So we did with 1 million without any errors. Okay. Last part is the scaling. So scaling is a X into Y into Z problem. X is the number of inventory, Y is our number of category, which is 5,000, and Z is our latency, turnaround time, which is 1 to 2 seconds in case of OpenAI. So in order to scale, all this X, Y, Z need to be scaled or optimized. So this is what we did in order to optimize all the X, Y, Z. So number one thing which we did is, first of all, within our 1 million SKU category, we run the cosine again and find out the redundancy, similar SKUs, which reduce heavily. Okay, so system did reduce heavily. Second part is we introduces Llama 3 and create, instead of calling a single API call, we convert it into a batch process. So it can call a batch API. So 500 SKUs in one API call. Third part is category. So 5,000 categories, we created category graph. So it will call for category number 1. Based on the output, it will go for the next level of categories. So that also reduce the API call to from 5,000 to 7. So this is what we happened in primarily for 1 million SKUs. It took us 25 minutes with $5 cost because Llama 3 instance is running. And running is on demand. So the moment you need to do the tagging in category, someone run the job and it is spawn the EC2 instance with the CUDA course. It takes only $5 and $15 for. So only trade-off is, earlier it was kind of real time. This time you cannot do real time. So our learning, again, it took us a lot of time, a lot of pain. So first thing, in my opinion, for AI problems, you should go for AI solutions. You should focus on robustness and resiliency like patterns I'll talk about earlier. Frameworks, I will talk about this. Now the question is, looking into this, if you're looking into a scaling system, should you use a framework like LangChain? So here is my opinion, and my personal opinion. You should not, and you should. So the reason is this. First of all, you need to learn how the multi-agents, all these things works. So for learning how the whole this paradigm works, you should build your system in LangChain. Parallelly, you should go into the LangChain code, take all the small libraries, tools and everything, create your own code base, okay? And start looking into how to optimize things. For example, one of the major problem like Neo4j is if you're trying to fetch a lot of documents, it's very hard to control, whether it's Elasticsearch or Neo4j. But if that connector is in your control, you can very handsomely control it. Okay? So here is the learning. You build your solution two part. One part is with the LangChain, another part is your own, parallelly, if your scaling is in your requirements. Time and cost and each iteration, I said, is a premium thing. So until unless you have that scope in the mind, even with the Llama 3, you need to spawn an instance, which is very costly. Okay. And last part is if you can figure out all the hallucination first before live, that is perfect. Okay. Otherwise, it's not worth go to the live. Hallucinate will kill your product. You will get a lot of issues. And yeah, so that's all from my side. Thank you.
Do we have questions for him? Yeah.
Wonderful presentation, sure. You were mentioning about the GD and instances that comes up with a cost. And I know that our in our product inventory, our keep on the SKUs are going to go up. Like, how can we handle that? Today it's 5,000 categories. Tomorrow it will be 5 million categories. And how do we scale up when
So
going forward?
remember XYZ. Figure out what are your XYZ, number one, and optimize all of them. That's the thing.
So how do we have the trade-off between the cost and
So trade-off is then you look for the infrastructure. Better if AWS doesn't have better instances, so can you go where the graphics card is there? I have seen people now buying the graphics card machine in their hand because it's cheaper. So that's also
so
in
we are
the,
currently using with respect to AWS, and we are using a higher GPU instances, and it comes with a cost.
yes, it's a cost.
So that is what.
So if the cost is consistent for let's say 2-3 years, then you can buy your own. Just buy 305, 390, create a CLI in the same system, and it will work. Yeah. Thank you.